I've got up on the board here the two graphs that are on the worksheet for this section, and then this list of 6 questions that we're going to work through in this video together. If you've got the worksheet printed out, you've got a cleaner version of these graphs. On those graphs, I didn't bother to label these points because grid lines are drawn in. Because I don't have the grid lines drawn in, I've labeled some of the important points. But I told you there, and I'll tell you now, that the grid lines on the worksheet and the tick marks here on the board are 1 unit apart, and points that look like they have integer coordinates do. Okay. What I want to do is just work through part of this together and then pause the video and have you work things out. Okay. So the first 3 questions are asking you to evaluate certain functions. Of course, that's always if they're defined. If you hit one that's undefined, you just write undefined. Let's work through the first of these together, and then I'll leave these 2 for you folks to do. Then the last 3 questions ask about the domains, and we'll talk a little bit about that, but I'll let you do most of that on your own. Okay. So for question 1, f plus g of 2. I know the way we evaluate that is we evaluate each function at 2, whoops, and then we add the results. So that's just going to be f of 2 plus g of 2. So a lot of what I need to do is just read the graph. So here's f. I'm going to come to where my x value is 2. And in this case, the y value I can see is 0 because that point is right there on the x-axis. So that's going to be 0. And now I'm going to do the same thing on g. I'm going to come over here to where my x value is 2. Ordinarily, I'd look for a point above or below that, but in this case, once again, the value is on the x-axis, so the y value is 0. So I'm just getting 0 plus 0, which of course will be 0. Okay. So I'll leave you to try problems 2 and 3. Let's just review a little bit of about domain. Now, I didn't ask you to find the domain of f and g individually, but I would always do that as a first step before finding the domains of any of these more complicated functions. So let's just review how we would find the domain of f. So I'm basically looking along here. Each vertical line that I can draw picks out every point on the plane that has a particular x value. So I'm just looking for where do I intersect the graph. And it looks like we start right here. We first intersect the graph when x is -2. And then as I move along to the right, I'm still intersecting the graph, still intersecting, until I hit 4. Now when x is 4, there is no point on the graph, and certainly if I go to the right of 4, there's nothing there anymore. So my domain would be everything from -4 to 4. The -4 is included because there is a point on the graph there. The 4 is not included because there is not a point there. Okay. So I'll leave this up. I'm going to suggest that you pause the video now to try to work out the remaining questions. Before you do 4, 5, and 6, as a preliminary step, I would strongly suggest that you write down what the domain of g is, and then you can start putting the pieces together to find the domains of these other functions that we build out of f and g. So go ahead and pause the video and see if you can work out these problems. Question 2 asked us to find f times g of 1. So I know that's just going to be f of 1 times g of 1. So again, I need to read each of these values off of the respective graph. So for this one, I'm going to come to the graph of f. Here's where my x value is 1, and I can see there's a point above it. Now, that's not exactly at an integer value, but I should be able to calculate what that is exactly because this is just a straight line here. And I can see this point is at 0, 1, and this point is at 2, 0. So I'm coming down 1 and over 2. So if I've just come over 1, I would have come down half of that distance. I would have come down a half. So the y value there will be exactly 1/2. And then for g of 1, I come over to the graph of g. Here's 1. I can see there's a point below it. And this is a point that here, I actually have marked it off because I hadn't drawn in the grid lines. The y value there is -4. I'm just going to write that as -4 over 1 since I'm multiplying it by a fraction. Then I can cancel, and that's going to give me a -2. Question 3 was f over g evaluated at 2. So if I look at this, I get f over g of 2. That would be f of 2 over g of 2. So I'm going to create this fraction. Looking on the graph of f, I can see when x is 2, my y value is 0. So I'm going to go ahead and write 0. Now right there, that tells me that this answer is going to be 0 if this isn't 0. Anytime I've got 0 on top of a fraction, as long as the bottom isn't 0, that gives me 0. But I do need to double check that it's defined. So I'm going to look over here on the graph of g. Here's where x is 2, and my y value is 0. Now I can't write that. We can't literally divide by 0. There was nothing wrong with my thought process. I know this is what I was being told to do, but it's actually not allowed. This is undefined. Make sure that not only do you write that it's undefined, but if in the process of working it out you had written that you were dividing by 0, cross that out. That is not a legitimate thing. There's nothing wrong with saying, hey, I think this is what I should do. Oh, I'm not allowed to go that way, but then you undo that. Okay, so make sure that you cross it off. Don't leave that on any work that you're submitting. All right, so the next 3 questions are asking about the domains. So before I had you pause the video, we said the domain of f was everything from -4 to 4, including -4, not including 4. Let's take a look at the domain of g. So if I take a look, looks like I start to have graph right here at this x value, which would be 1, 2, -3. And there is a point there, so we'll include -3. And now I've got graph, got graph, got graph, got graph, got graph. Cease to have graph once I pass this point. And the x value of that point would be 2. Now there is a point there, so the domain of g is this closed interval from -3 to 2. All right, so for question 4, we're asked to find the domain of f minus g of x. Now remember, what that means I would do is I would evaluate f, so it's got to be in the domain of f. Then I would evaluate g, so it's got to be in the domain of g. And then I would subtract the results, and I can subtract any numbers I get. So we're just looking at the intersection of these 2 domains. I really like to find that by graphing on a number line, although it's not absolutely necessary. So let's see, we would be going from -4 to 4, this half open, half closed interval for f. And then for g, we'd be going from -3, which is going to be a little bit to the right of -4, to 2, which is a little bit to the left of 4. So now, if I look at what's shaded twice, turns out what I'm going to get is just everything between -3 and 2. So in this case, everything that's in the domain of g is also in the domain of f. So I get for free that if I can evaluate it at g, I can also evaluate it at f. So my domain of f minus g of x would be this closed interval from -3 to 2. It coincides with the domain that we just got for g. All right, now the last 2 questions ask about the domains of our quotient functions. So it's kind of nice that we've done this because that's our starting point. We have to be in this interval between -3 and 2, including the endpoints, if we want to be able to evaluate both f and g. But when we're dividing, we have to remove a couple of points, possibly. So here, we've got g in the denominator, so the value of g isn't allowed to be 0. So I want to take a look and see what x values are going to make g equal 0. And so that's where the y value is 0. So I'm looking for where we're on the x-axis. And it looks like there are 3 points. There, and there. The x value here, I'm just going to write that x can't be these numbers. So I'm going to have to remove them from the domain. X can't be -3. X can't be 0. And x can't be 2. So both of these endpoints are going to become parentheses because we're removing them, but we're also taking out 0. So if I were to graph this, we'd have -3 to 0 to 2, excluding those 3 points. So that's going to be a union of 2 intervals. So for question number 5, we're getting -3 to 0, union 0 to 2, not including any of those endpoints. Okay, question 6 asks about the other quotient that we can form, which would be g over f. So now f is in the denominator. So again, I'm going to start with the intersection of my 2 domains, which was the interval from -3 to 2. But now I've got to remove any x values where f is 0. So if I look, where is the y value 0? That's right here, just one point that I have to remove. And it looks like that's going to be 2. So for question 6, I'm going to get everything from -3 to 2, except I've got to say that x can't equal 2. So that's going to just change the punctuation here from a bracket saying we can include 2 to a parentheses saying that we can't. Okay. And actually, if you think about it, when we were asked earlier, we were asked to evaluate f over g of 2, and we got that it was undefined. Notice we confirmed that when we just calculated the domain in question 5, and we said 2 was not in the domain because that would make g equal 0. Okay. All right.